All right, hello everyone, this is Mr. Crozier. I'm going to give you another walkthrough on page 205, problems 1 through 8 for our test here. Problem number 1 says, consider an angle of 5 pi over 4. Well, hopefully we know that if you take 180 and divide it by 4, that's 45. So it's 5 45s. 1, 2, 3, 4, 5. It's this angle down here. And part B says 2 coterminal. Well, you take this and add on another loop around the circle, which is 2 pi, and 2 pi is also 8 over 4, 13/4. Subtract the loop, and you're here. So all of these three angles, angle 1, 2, and 3, all end up in this location. Just sometimes you go around an extra time around the circle. And convert to radians. Well, you probably have that memorized, but here's the work. I take the 5 pi over 4 and I add on this word radian right here, and I'd put pi radians is 180 degrees, and these will all cancel out, and we're left with 225 degrees. But adding the word radian here just kind of helps you from making silly mistakes. So know this conversion factor, 180 is pi radians. Number 2 is a truck that's moving 105 kilometers per hour, and we need to change it into radians per minute. Well, this is an example of linear speed. Linear speed changed to angular speed. Well, we start with our speed. I change the kilometers to meters, and then I put in this one conversion factor right here, and this is the trigonometry part of it. 0.5 meters, which is half of this, is a radian or a radius. Radian, radius, same thing. So this converts it from linear distance to angular distance. And now I just have to switch the hours to minutes, type it in my calculator, type across the top, divide across, or multiply across the top, divide across the bottom, and you have radians per minute. But there's always this trig conversion that switches from distance to angles, and right there it is. And what you just need to remember is that the radian distance is the same thing as a radius. That's what we did when we measured radians. Number 3. It is a sprinkler problem. We have a sprinkler shooting out right here, and it's shooting out 25 degrees, and it's going around, and it rotates for 130 degrees. So it's covering this area. Well, what is the area that is covered? Well, an area of a circle is pi r squared, so a sector is pi r squared times degrees over 360. Now you could do it in radians, but if they give it to you in degrees, might as well do it in degrees. So we just take this formula and add on degrees over 360. Well, we have pi in here, which is going to give us an estimated answer, so let's not even use pi. Let's take 25 squared times 130 divided by 360 and see what we get. Well, we get this decimal. We don't want to round, so let's go ahead and change it right into a fraction. And there's our fraction. And that's a mixed number. It's 225 and 2536. Well, let's go ahead and change it to an improper fraction. So there's our fraction. 8,125 pi divided by 36. That's our answer. Now, if you want to go ahead and do a decimal approximation for that, you can at 709, but the exact answer is what we're usually always looking for. So don't round to this unless it specifically asks to, and it does not. So we're going to leave it as this. Number 4. The angle is 7 pi over 6. Well, that's right here, right? 210 degrees. Well, that's on the unit circle, so we know these measurements. And now we can find the trig values. And those should all be, oops, we have a 3 here. These should all be, you should remember all of these from the unit circle, right? Sine, cosine, divide them, you have the tangents. All right, number 5. Now we have a triangle, and it tells us that the tangent of theta is 3/2. So you take this information and you draw the triangle, and when you draw the triangle, you have everything but that 13 right there. And then what you can do is you can work backwards with the Pythagorean theorem, figure out what the hypotenuse is, and then plug in, and again, give the exact values. Sine is opposite over hypotenuse, 3/13. multiply top and bottom by root 13, and we have 3 root 13 over 3, down, down, flip them for your inverse operations. Number 6, they give you the point -2, 6 for the cosine, or they give you this as a point, and you can draw a right triangle, and Pythagorean theorem, figure this out. Well, 40, remember, root 40 is really root 4 times 10, which is 2 roots of 10, so use that simplified version right there. And then when you do sine over cosine, well, the sine value is the opposite, 2 root 10 over 6 divided by 2 root 10 over 3. And then cosine 1/3, and tangent would be the opposite, which would be 2 root 10 over -2, which would be negative root 10. Take the inverses. Problem 7, we're looking for secant less than 0. Well, secant matches cosine, right? SC cosine here. And we do this statement, all students take calculus. Well, where's cosine negative? Cosine is negative over here. Because this tells us, if I rewrite it here, all students take calculus. Cosine's positive in these two. Well, where's tangent positive? Well, tangent's positive in these two. So we have these two. So the answer is down here. Quadrant 3 is in both of them. And the last one, it gives us this statement right here. It says cosine of theta is negative root 3 over 2. And it wants possible theta, so we have to work backwards. But it says without a calculator, and it says exact values. So when it says exact values or no calculators in trig, that means you're looking at unit circle stuff. Well, where is cosine negative 3 root 2? Well, that's this long side right here. And it makes this short side right here. So it makes this 30, 60, 90 triangle. And that's only up 30 degrees, 30 degrees. So the two angles here are 150 and 210. And you can always check that on a calculator, right? You put in cosine, whoops, I'm in radians, switch to degrees. Cosine of 150 degrees is negative 0.866. Let's write that down, negative 0.866. Now if we do the negative square root of 3 divided by 2, we get that same decimal, so that checked. Now let's check the next one, cosine of 210. Same decimal. So you can verify it with a calculator. All right, hope this helps with the problems on page 205.